So in this real-world example problem, I'd like to consider the act of cycling, bicycling if you will. So you have pedals, and the pedals are attached to a pivot point, and when you apply a force on the pedal, it starts moving around and around. Now let's assume that you are exerting a 70 Newton force at an angle of 55 degrees above the horizontal to the pedal when it is creating an angle of depression with the horizontal of 25 degrees. I would like to calculate the torque, or the magnitude of the torque, about this point. Calculate the magnitude of the torque. Now do keep in mind here that we do have that formula from the previous video. The magnitude of the torque is equal to the magnitude of the radius times the magnitude of the force times the sine of the angle in between the two vectors. Now the good news is we were given the magnitude of the radius as 22 centimeters. We were given the magnitude of the force as 70 newtons. What we're going to have to do is do a little bit of angle chasing in order for us to actually figure out what the angle between these two vectors is. So technically we would need to move this force so that its initial point is at the same place as the torque. Now, if we draw in another horizontal here, good news is I think that we can follow these angles. Alternating interior angles should have the same magnitude, and then I believe this is going to be a 55 degree angle as well. So if we add up those two angles together, we're going to wind up with an 80 degree angle. So with that in mind, let's go ahead and theta is 80 degrees. Oh yeah, I guess if we take the terminal point and the terminal point and the initial point and the initial point, we should see the same angles. So one other thing that we're going to do here to try to keep things SI is we're going to convert our 22 centimeters into meters by dividing by 100. So 22 meters times magnitude of the force, that's 70 newtons, and then we're going to multiply by the sine of 80 degrees. For good measure, let's go ahead and round that off at the second decimal place. Grab our handy dandy graphing calculator that is just so handy. Make sure that we're still in degree mode up in the mode menu. Looks good. 22 centimeters, 70 newtons, sine of 80 degrees. Looks like we are dealing with a total of 15.17 approximately. Multiply a newton times a meter, got yourself a newton meter. Or about 15.17 joules. Keep track of those units. Real world problems require real world numbers, units, however that meme goes.